All right. The problem is that sometimes things don't work the way we want. Let me show you this now. Let me show you this problem. The same problem that we were just working with. Let's look at this function. All right. But now I want to rotate this region, all right, over the y-axis. What's the difference between what I'm doing now and what I did before? Is that when I rotate here, look what will happen around the y-axis. You will have to rotate this segment, not all of the segment, because this part we don't want. We want this region only. So I have to rotate this segment. And rotate it around the y-axis. You see? So it doesn't give me a disc anymore. Doesn't give me a disc shape anymore. It gives me a donut shape. It doesn't give me a disc shape because there is an empty part between the line of revolution. This is empty. So when I rotate, I'm going to rotate not the full thing around the y-axis because it's not on the y-axis. There's an empty part, a hollow part here. So when I rotate around the y-axis, I have to rotate this segment. What will I get? I will not get a disc shape anymore because this is what will be filled and this inside will be empty. So what will I get? I will get a donut shape. What happens? How do I solve this problem? How will I get the volume then of a solid of revolution that is hollow? So you will see it will be filled from here because of the rotation, but it will be hollow from inside. All right, let me try to show you a better graph. This is the line of revolution. So when you take this segment and revolve it, it will look like this. Yeah, this is the filled part. And the rest of the disc is hollow. You see? Here, it will be like this. And then it goes up. It becomes hollow from inside. What do? I will use my discs method, but refreshed in a certain way. See, again, how do I get volumes? Volumes are, again, always imagine, volumes are integrals over the region. You find your x, find your limits, area in terms of x dx. This is if you're rotating about the x-axis. If you're rotating about the y-axis, you find your limits of y, area with respect to y of the region you are rotating, a sample region that you are rotating, and you integrate with respect to y. That's what we always have to do. See, in previous examples, the regions were disks, so their areas were pi r squared. It's very simple. Here we have donut shapes. Who can tell me how to get the area of a donut shape? How to get the area of a donut shape? So this is a donut shape. How to get the area of this donut shape? It's very simple. The area of a donut shape is the area of the big circle minus the area of the small circle. What's the area of the big circle? I will call the radius of the big circle the outer circle O and the inner circle I. So the area of the big circle will be pi r outer squared minus the area of the small circle, which I r inner squared. So what's the area of a donut now? V, the volume, in terms, whether in terms of x or in terms of y, will be the integral from x equal a to x equals b, and the area of a donut shape now is pi taken as a common factor, outer radius squared minus inner radius squared dx. And in terms of y, it will be y equals a to b, pi r outer squared minus r inner squared, but dy. Here the functions should be functions of x, here the functions should be functions of y. So going back to our example that we had over here, how will we handle this? Once you understand that volume is nothing but the integral of the area of the region, it becomes a question about what is the area of the simple two-dimensional region that you are getting. It's either a disk or a donut. So let's look at this. Y equal x squared here. Y-axis, we're rotating around it. Which region? This region that we have over here. So we take a sample representative in the region. This is a sample representative in the region from y equals 0 to y equals 1 over here. And again, the first thing that you have to do every single time you are working with these questions is ask whether the functions should be functions of x or functions in y. Since we are rotating about the y-axis, the functions should be functions of y. So x equals root y. We directly change it. So now what will happen? We take a representative of our region with a horizontal line, because again, when we are in the parallel y world, our lines are horizontal in the segment. So now what will my outer radius be? What will my inner radius be? So always radii are measured from the line of revolution, because when I turn this around, I'm turning it around what? I'm turning it around the y axis. So the radius is always from the line of revolution. That's what I always said. The radius will always be from the line of revolution. All right. So now the outer radius is all of this. The donut says the area of the donut is pi common factor, the outer radius, which is the distance between the line of revolution and the outside part, which is here. That's the outer radius. And the inner radius is the distance between this and this, the part that we don't want, the hollow part. So you have to take it away, the hollow part. So what is the outer radius here? Always distances, either you measure them above minus below or right minus left. This has what function? Has y equals 1. So it's 1 minus, this has what function? Sorry, x equals 1. This has what function? X equals 0. So it's 1 minus 0. Now the inner radius will be what? It will be this minus this. What is this? This is x equals root y minus x equals 0, that is over here. So the outer radius here is 1, the outer radius here is root y. Then the area of the donut will be what? It's the area, the outer area of the circle minus the inner area of the circle. So the area of the outer circle minus the area of the inner circle, which means I take pi common factor. It's the outer radius squared minus the inner radius squared. That's the area of the donut. Now the volume will be what? The volume will be the integral from 0 to 1. These vertical lines happen all through the region. From where to where? From the beginning of the region at 0 to the end of the region, which is 1. So from y equals 0 to y equals 1. Pi 1 minus y, because we have 1 squared minus root y squared dy. You take pi as a common factor. You are left with 1 minus y dy, which is very simple to integrate. The integral of 1 is y. The integral of y is y squared over 2 from 1 to 0. Do not forget your pi. This means you get pi. Y, when you substitute 1, it's 1 minus 1 over 2. Minus, when you substitute 0, you get 0 minus 0. So it's pi half or pi over 2 cubic units. All right. The more examples we solve here, the better you become. If you do not solve a lot of examples, you do not understand the idea. Especially, you have to solve those examples before you move to section 5.3, because in 5.3 they give you another way of solving exactly the same thing, finding volumes, but in another way, which makes things very hard on us to visualize. So now what have we done so far? We have learned how to get the volume of a solid of revolution. But now we have two scenarios that we have learned. The disks, and what we just did with the donut is called the washer's method. Here we get, when I revolve, I get a disk. Here when I revolve, because there's an empty part, what do I get? I get a donut. The area of a disk is pi r squared. The area of a donut is pi outer radius squared minus inner radius squared, because it's the area of the outer circle minus the area of the inner circle. So now what we need to decide before doing a volume of a solid of revolution, is it a disk or a donut? That's the first question you ask. To know if it's a disk or a donut, what should you do? You should look at the region you are rotating, and you should look at the line of revolution. If the region is stuck to the line of revolution with no empty spaces, this forms a disk, because then you will rotate, you get what? A disk that is full completely. If you are having an empty part, so you're rotating around this line, like the one that we just did. What happened here? There's an empty part between the region and the line of revolution. Do you see this hollow part? So there's an empty space. What happens when we have an empty space? When we have an empty space, this will cause for us to have what shape? A donut shape when we rotate. So you rotate a segment, the segment has a space with the line of revolution, which means that this will form for us a donut, and we need to use the other formula. What's the second thing you need to decide? The second thing that you need to decide is whether you are going to use dy or dx. Meaning, should your functions look like x equals f of y, or should your functions look like y equals f of x? Should the limits be limits of y, or should the limits be limits of x? Which one of those scenarios do you choose? How do you choose? If you are rotating with respect to the x-axis, it's dx. If you are rotating with respect to the y-axis, it is dy. It's a very simple story so far. All right? So if you're rotating with respect to the x-axis, directly you look at your formulas and you make sure your formulas are all looking like y equals a function in x. If you're rotating with respect to the y-axis, you directly take a look and x should be a function of y rather than otherwise. Let's look at another example. Let's look at the function y equal 4 minus x squared as it is bounded with the x-axis. 4 minus x squared, of course, is the parabola. I will only take the part that is on the right. The other part is the same. It's symmetric. So when we rotate 360 degrees, this part and this part will overlap. So I'm only going to take the part that is here, 4 minus x squared, when x equals 0 and x equals to 2. All right, 4 minus x squared. This is my region. I want first to rotate it about the y-axis. I'm going to use the same scenario and rotate it in different ways. This is the region that we are talking about. And we are going to rotate it about what line? The y-axis. The moment I read I'm rotating around the y-axis, then directly what do I say? dy. dy means directly the function should look like f at y. So I should change from y equal f of x to x equals f of y. So here x squared is equal to 4 minus y. So x, since it's positive, is equal to positive root 4 minus y. This is the function that I have to use. What is the y ranging from? So now I read horizontally. For the y-axis, it's always horizontal lines. Because again, you imagine this function, this is my line of revolution. This over here is my line of revolution. And I'm rotating around it. So how will my shapes look like around this? They will look horizontal. So what kind of segments will I be running? Horizontal segments. So now, how do I form? Is there a space between the section and the line of revolution? No. So is it Wilshire's method or the disks method? It's the disks method. What's the area of one disk? The area of one disk is pi r squared. So the volume, since we are rotating with respect to the y-axis, v of y is equal. The integral from y equals 0, it finishes at y equals, here 0. From y equals 0 here to y equals how much here? 4. What's the area of the disk that I'm looking at? It's pi. How much is this radius? It is the x value here minus the x value here. This distance. How much is this? This is root 4 minus y minus 0, since we are on the y-axis, squared dy. And when you square, of course, it becomes 4 minus y. The integral becomes very easy. Pi 4y minus y squared over 2. From 4 to 0, you keep the pi outside. You substitute the 4. 16 minus 16 over 2, which is 8. Minus 0 minus 0, it gives me 0. 16 minus 8 is 8 pi cubic units. Alright? All as functions of y. The same exact region. Look at the same exact region, but I want to rotate it now around not the x-axis, not the y-axis. Alright, I want to rotate it now about the line y equal minus 3. The line y equal minus 3 is this horizontal line. Remember, lines y equal a constant are lines middle y equals 0. They are parallel to the x-axis. X equals something are vertical. Y equals something are horizontal. So we want to rotate around this line. Tell me, what shall I do now? It goes the same way. This line behaves like the x-axis, but now its formula is different. And let me show how this changes things. First, I need to ask myself, what is my line of revolution? It's y equals minus 3. How does that behave, like the x-axis or the y-axis? The x-axis. The moment I read x-axis, معناتها I know that. How will I work? I will work dx. So this means my functions should be functions of x. So this is perfectly fine. The limits that I'm going to work with are limits of x. And it makes sense. See, this is being rotated around this line. Alright, so what kind of line am I going to consider? I'm going to consider this vertical line. See, with respect to dx, we are always drawing vertical lines. So what happens here? This is the region I'm going to deal with. And this is the line of revolution. Is there an empty space between them? Yes. When there is an empty space, we don't use the disks method. We use Washer's method. In Washer's method, what should I worry about? I need the area of a donut. For an area of a donut, I need the area of the outer radius minus the area of the inner radius. The area of the outer radius, the outer circle needs the outer radius, and the area of the inner circle needs the inner radius. So how do I get the inner radius and the outer radius? You have to follow my directions or you will be lost. You always start from the line of revolution to get the radii, because you are revolving around this line. So the outer radius will always be from the line of revolution. Never measure the radius except from the line of revolution. The outer radius will be all the way to the outside function very far away from you. The inner radius will be from here to the part that you don't want. It's the inner radius, it's the hollow part that you do not want. The outer radius is the full thing. The inner radius is the part that you do not want. You find them separately. You write them R outer, R inner, so you do not get confused. So write R outer and R inner, so you do not get confused. How do you get those? Always, it's the upper minus the lower, since we are dealing with vertical lines. So the outer radius, which is all of this segment here, how much does it measure? What's the distance? It's the upper y value, which is 4 minus x squared, minus the lower y value, which is y equals minus 3. So it's 4 minus x squared minus 3, which is plus 3. So we get 7 minus x squared. What's the inner radius? This is the inner radius. The upper is y equals 0. The lower is y equals minus 3. So 0 minus 3 is 0 plus 3, which is 3. So we got the outer radius and the inner radius. And then what does the formula say for the area of a donut? The area of a donut is pi, the outer radius squared, minus the inner radius squared. So it's equal to pi 49 minus 14x squared plus x to the power 4 minus 9. So it's equal to pi minus 14x squared plus x4 plus 40. Now what do we do to get the volume? The volume is a volume of x, because we are rotating around something similar to the x-axis, which is integral from x. Where is x starting? X starting at 0, finishing at 2. So from x is equal to 0 to x equals 2 of the area of this donut dx. You integrate one by one, and you substitute 2 and 0, and you get the answer cubic units. The answer will be 1472 pi over 15 cubic units. All right, so let's look at the same region, but now I have a third line of revolution. This is, by the way, example 7 in the book. The line y equals 7. This is the region. All right. And this is 4, y equals 7. This is the line y equals 7. We want this as our line of revolution. See? This is our line of revolution. Is it parallel to the x-axis? Yes. X-axis يعني dx. يعني functions are functions of x. Limits are limits of x on the integral. What else? X-axis, we draw vertical lines in order to define lines in the region that we are going to rotate. We're going to rotate this line. This line will be rotated around all of this, forming our, since we have a space, then we are going to form what? Donuts and not discs, of course. How do I find the radius of the donut? It's very simple. Where do we start our measurement? We start from the line of revolution, always. We always start our radius from the line of revolution to the outside. مش هي a segment إلى 2 points the segment in the region. 1 point is away, 1 point is close. The outer radius is from the center on the line of revolution to the point away. And how much is this? This is the upper y minus the lower one. This is the x-axis, so y equals 0. So we get 7. How much is the inner radius? The inner radius is from the line of revolution to the point that is close. So the far away, the outer, the inner, the outer, the inner. All right, so how much will that be? It will be 7 minus, what's the y value over here since we are on the function? 4 minus x squared between brackets, or you'll get a wrong answer. So it's 7 minus 4 plus x squared, which is 3 plus x squared. Now, once I get the outer and the inner radius, the volume with respect to x becomes very simple. It's the integral starting from x equals 0 to x equals 2 of, what is the area of a donut? The area of a donut is pi outer radius squared minus inner radius squared dx. You throw the pi outside, you expand 49 minus 9 minus 6x squared minus x to the power 4, which is 40 minus those, and you integrate one by one and you get the answer. I do not need to continue. So see, it's the same idea over and over again. If you follow the steps, you cannot go wrong. The same problem I want to rotate it, this region. I want to rotate it now around the line x equals 3. X equals 3. It's a vertical line. Vertical lines behave like which lines? Behave like the y-axis. Oh, I read y-axis. يعني dy. يعني the function y equal 4 minus x squared is no longer good. What should I use? They should look like functions of y. So I have to rewrite it as x squared equals 4 minus y, which means x equals root 4 minus y. And this is the function that I'm going to use. Is there a space between the region and this? Yes. So what do we have? We have donuts, not discs. So Washer's method. How do I get Washer's method? I need an outer radius and an inner radius for my donut shape. To get the area, I need the area of the big circle minus the area of the small circle. To get areas of circles, I need the radius. To get the radius, I start first, I draw a representative segment in my region. See now, I'm no longer drawing vertical segments because I'm working with respect to something similar to the y-axis, which is x equals 3. So over here, I draw what kind of segments? I draw horizontal segments. I was doing like this. All right, horizontal segments. So this is the segment. From the line of revolution to the point far away, that's the outer radius. From the line of revolution to the point that is close, that's the inner radius. How do I calculate the measurement? It's always the right minus the left when I'm working horizontally. The right is 3. The left, this is x equals 0. So 3 minus 0, it's 3. The inner radius is the right, which is 3 again, minus the left, which is on the function. So it's equal to how much? Root 4 minus y. So now how do I formulate the problem? V, because it's around a line parallel to the y-axis, so we call it Vy. Vy is equal to pi, throw it outside if you want from the beginning, integral. Y is ranging from 0 to 4. of the outer radius squared minus the inner radius squared dy. How to integrate this? From 0 to 4, 9 minus 9 minus 6 times minus becomes plus 6 root 4 minus y. This becomes 4 minus y, root 4 minus y squared is 4 minus y, and there's a minus here, so it's minus 4 minus y. You can expand it step by step into if it's easier for you. 9 minus 9 cancels, you are left with pi integral from 0 to 4, 6 root 4 minus y minus 4 plus y dy. This is easy to integrate, it's minus 4y. This is easy to integrate, it's y squared over 2. This one needs to use u du substitution. If u is 4 minus y, du is minus 1 dy. So you have to multiply by minus and divide by minus outside. So it becomes minus over minus to be sorted out. Take it on the side if you want. So using this, you have to multiply by minus in and out. So you get minus, and the 6 throw it outside. You are left with this. This becomes minus sine is integral root u, and the minus dy becomes du. Root u is u to the power half. You add 1, it becomes u to the power 3 over 2 times 2 over 3. U to the power 3 over 2, which is minus 12 over 3 minus 4 u, which is 4 minus y to the power 3 over 2. So when you integrate, this gives you pi minus 4 minus y to the power 3 over 2 minus 4y plus y squared over 2 from 4 to 0, and you can calculate the answer. Cubic units. I can take the answer over here. Let me tell you what it is. Yeah, no, I can't calculate it. Alright, yalla break.